All right, year 10. So now we are looking at what happens if we have an expression where the coefficient of x squared is not 1. If the coefficient of x squared is not 1, we need to deal with that before we start completing the square and factorizing. So the first thing we're going to do is factorize out the coefficient of x squared. So we're going to say 2 outside of. Now, 2x squared divided by 2 is x squared. 4x divided by 2 is 2x, and 18 divided by 2 is, or negative 18, becomes minus 9. Now we go about completing the square. So 2 over 2 is equal to 1. 1 squared is equal to 1. We're going to write our full expression. So 2 bracket x squared plus 2x plus 1 minus 1 minus 9. From here, we complete the square. We get 2 bracket x plus 1 squared minus 1 minus 9, all in brackets. Okay, so I'll rewrite that again up here. So we have 2, I'll use square brackets to indicate the outer brackets. We have x plus 1 squared minus 1 minus 9. Simplifying our constants, we have 2 outside of x plus 1 squared minus 10. And now we're going to use our DOPS, our difference of perfect squares, only on the section inside the brackets. So the 2 will remain outside. And we will get the square root of x plus 1 is x plus 1. Sorry, the square root of x plus 1 squared is x plus 1, minus the square root of 10, plus the square root of 10. X plus 1 minus the square root of 10. And that is our final solution. The most notable thing here is the fact that that 2 that we factored out has stayed throughout our entire equation, our entire working process. All right, the next example. We have negative x squared plus 4x plus 3. It's important to realize that negative 1 is not the same as 1. This still needs to be factored out. So we have negative 1 outside of x squared plus, minus 4x minus 3, where the symbols of each term have changed. We go about completing the square. So minus 4 on 2 is equal to minus 2. Minus 2 squared is equal to 4. Minus 1 outside of x squared minus 4x. And we're going to add our 4, subtract our 4. And then the minus 3 comes after. We complete the square. Minus 1, I'm going to use square brackets now because we're going to have our x minus 2 squared minus 4 minus 3, which will leave us with minus 1 outside of x minus 2 squared minus 7. Now, we're not going to leave in this form. We are going to apply our difference of perfect squares. So, once again, we have minus 1 outside of x minus 2 all squared, minus 7. I'm going to apply DOPS to the section inside where we have our a squared minus the b squared. Okay, we're treating 7 here as b squared. So we will have minus 1 outside of x minus 2 plus root 7 and x minus 2 minus root 7. Now, being a negative 1, we can just write this as negative outside of x minus 2 plus root 7, x minus 2 minus root 7. That is our final answer. The final example, C. We have negative 2 as a coefficient of x squared. So we will take the negative 2 outside. we will have x squared plus 4 on negative 2 becomes negative 2x. And 5 on negative 2, we're just going to leave as minus 5 on 2. We complete the square. Minus 2 on 2 is minus 1. Minus 1 squared is equal to 1. We're going to add and subtract it into our equation. So we will have our x squared minus 2x plus 1 minus 1 minus 5 on 2, all in brackets. From this point, we are going to complete the square. So we will leave our minus 2 out front. We will end up with x minus 1 squared minus 1 minus 5 on 2. We're going to collect our like terms at the end. So we have minus 2 outside of x minus 1 squared. Minus 1 minus 5 on 2 is the same as minus 2 on 2. Minus 5 on 2, so we'll have minus 7 on 2. When we use dots, we'll have minus 2 outside of x minus 1 plus root 7 on 2 x minus 1 minus root 7 on 2. Now, remembering our surds, if you have a surd fraction, always rationalize. So we will have x minus 1 plus root 14 on 2. X minus 1 plus root 14 on 2. Good luck.